Okay, hi guys. So in from this lecture, we'll be seeing the quantum numbers which we discussed in the previous lecture, wherein we saw principal quantum number, azimuthal, magnetic, and spin quantum number. So let's get started first with seeing principal quantum number. Okay. So this quantum number tells about filling of electrons in a shell and also explains the size or volume of the electron cloud outside the nucleus. Okay. It also represents total energy associated with the electron. Okay, so this tells about filling of electrons in a shell. Second, also explains size or volume. This is very important. Size or volume of electron cloud outside the nucleus. Next, represents total energy associated with the electron. Represents total energy associated with an electron. Okay. Then next we'll be seeing that what are the permitted or possible values of n. So those can be positive integral values except 0. So n belongs to the open interval 0 to infinity, where n belongs to I. Okay, any positive value is acceptable. Okay, so value of n represents shell as well as the period number of atom of element. Okay, so value of n represents shell number as well as period number of atom okay. So let's say n was 1 2 3 4. Okay, so shell under consideration would be K, L, M and N. Okay, so let's see that for any value of n, total number of subshells that is L would be n, total number of orbitals or M would be n square, and total number of electrons would be 2n square. That can be accumulated in a shell. Okay, so next let's see azimuthal quantum number. So this is also called angular quantum number. Okay, so this quantum number defines filling of electrons in subshell, okay, and also tells about shape of electron cloud in 3D space. Tells about filling of electrons in subshell, which is sub energy level, and then also tells about shape of electron cloud in 3D space. Okay, so this quantum number is also known as angular quantum number, which I have already written, and because it measures the orbital angular momentum of electron. So what is orbital angular momentum? So orbital angular momentum is defined or is written as, the formula is h upon 2 pi under root L into L plus 1. Okay, so just remember this formula by heart. This is a very important formula. Okay, so next, what are the permitted values of n? Permitted values of L would be, it depends upon the value of n. For any value of n, we can write that the values of n would be, so first let me write out down, that depends upon value of n. Okay, hence for any value of n, values of L can vary from 0 to n minus 1. Okay, so total values of m would be 12 plus 1. Okay, and total number of electrons in a subshell would be 2 times 12 plus 1. Okay, so each value of L actually corresponds to a subshell. Okay, so let me write it down, that each value of L corresponds to a particular value of, or to a particular subshell. Okay, so let's say we have azimuthal quantum number here. Okay, and we have a subshell. So let's say this is 0, 1, 2, 3. So for 0 we have S, for 1 we have P, 2 we have D, and 3 we have F. S is nothing but standard, P is principal, D is deferred or rather diffused, and F is fundamental. Okay, so we will be continuing on seeing more on azimuthal quantum number and rest of the quantum numbers in the next lecture. Till then, good luck and goodbye.